I think it's recording. Yes, it is. Alrighty, so we are recording right now. What I want to remind you guys that you have the test over the atmosphere Friday, and we are going to review first the stuff we studied last week. We learned about the atmosphere, and then we're going to pick up some new stuff about heat transfer. So that's why I wanted to record our lesson so that we'd have it today. First, we learned about the composition of the atmosphere last week, and that means all the chemicals that are in the atmosphere. All right, nitrogen is the most of it. Even though we breathe oxygen, we think should be the most, but it's not. Oxygen's only 20%. The bit is nitrogen. All right, and so let me go ahead and full screen this. Okay, that means I'm not going to see you guys with your hand up until I look at the other screen. So y'all just speak into the mic if you need me, because I won't see your hand because I put this bigger so you can see it. I'm trying to see if this is even better. Make the picture big as possible. Let's see. Control plus. That's better. All right, so now that's a nice big screen for you guys. Hopefully we can see the pictures as we go. All right, so we learned that even though oxygen is the most important part, it's only 20% of the atmosphere. The biggest chunk is nitrogen, which is actually no good to anybody at all. We'll learn about that in the gas form. It's not really any good to anybody. So we're going to learn about that when we do the nitrogen cycle. These little small pieces right here, this is what I want to talk to you today. It's going to bring us into the greenhouse gases. These are the tiny little chunks. The three big hitters on greenhouse gases are carbon dioxide, methane, and water vapor, and they're included in these tiny little sections. This pink one, this tiniest of all, that's the carbon dioxide. And you know that every time you hear people complaining about the climate change, they're talking about too much carbon dioxide because that's what we put out when we do fossil fuels. Well, it's that tiny little sliver. So that tiny, tiny little sliver of carbon dioxide can cause all the big trouble that we have in our climate change. And yes, because it's that powerful. Mixed in with the yellow is another big heavy hitter that's called methane. Methane has a lot to do with farming. It comes from the grasses digesting. So as the grasses rot, and the animals who eat the grasses let out their waste gases. All right, animal poots are full of methane. And right now we know that there are more cows on the planet than there are people. So that's a lot of methane. Methane is even more powerful than carbon dioxide as far as filling up the atmosphere. But these are tiny little slivers, tiny little amounts of these big hitters, carbon dioxide, water vapor, and methane, to cause all of this damage. All right, so try to remember, if you can remember, the atmospheric composition. When I ask you the composition of the atmosphere, I'm asking for the chemicals that are in it. All right, now the atmosphere is divided up into layers. The troposphere down here is where we live. This is where all weather happens. Air is affected by gravity, so that most of the air is down here at sea level where we are. That's why our summers are so hot and sticky, because there's so much air. We live at around sea level, and Louisiana is even worse. So the closer you are to sea level, the more air presses down on you. But as you climb a mountain, the air gets thinner and thinner. That's one of the reasons it's colder on the tops of the mountains. And also when you go to the big mountains, like Himalayas and stuff, you actually have to carry oxygen with you. But this is the troposphere. This is where we live. All right, it goes up about, it says 12 to 18 kilometers. It's about 10 miles. It goes about 10 miles up. The next layer is the stratosphere. Now, inside the stratosphere is a real important layer called the ozone. That's this second picture here. The ozone is part of the stratosphere. Okay, the ozone is part of the stratosphere. And the ozone protects us from ultraviolet rays, these big, nasty, bad ones that would burn us. This UVA that comes through, that's basically just light. Okay, that's not going to hurt anybody. This UVB, that's the one that burns us. And UVC is crazy ridiculous. We are so glad that the ozone blocks all of that. All right. And so what we learned about the ozone is that it blocks 95% of these UVB rays, only 5% come down. And that the hole in the ozone layer was caused by some pollutants that we had been putting in the air, called chlorofluorocarbons, CFCs. They made a hole in the ozone layer, and it allowed too much of this UVB radiation come down, so much because the hole settled over Antarctica and Australia. And the kids in Australia had to wear sunscreen all the time, no matter what, when they went outside, because the cancer rates were so high because of the hole in the ozone allowing this UVB to come through. causing skin cancer. What we found out is that when the biggest of the volcanoes explode, they can throw gases up in the atmosphere, and only the biggest ones can get their ash and other high up that it actually started to knit together, fix the hole in the ozone. It's not 100% yet, but we've also banned the CFCs. We don't use them anymore. So hopefully the Earth can heal herself. And see, that's one of the amazing things about what we do in ecology and environmental science. The next layer, so that's stratosphere. The ozone is part of the stratosphere. The next layer up is the mesosphere. Its job is to protect us from meteorites, M and M. Mesosphere protects us from meteorites. They burn up, and that's what we see as shooting stars. Thermosphere is the next layer up. Inside the thermosphere, you have the ionosphere. Just like the ozone is part of the stratosphere, the ionosphere is part of the thermosphere. The ionosphere is the one that protects us from the worst of the solar radiation. The ozone protects us from UVA and UVB. That's fine. But the sun is also putting out scary stuff like X-rays and gamma rays. Gamma rays like turn the Hulk green gamma rays, okay? The ionosphere protects us from that. But what's cool and interesting from our perspective, when the solar radiation hits the ionosphere, it makes sparks. And these sparks are what we see as the northern lights in the places like Alaska and Canada. All right, so the ionosphere protects us from the nastiest of the solar radiation, X-rays and gamma rays. And then higher up is the exosphere. Exo for exit to space. And what it is, it's not a hard line like this. It is not a hard line. It's just less and less air molecules as you go, and you just look around and all of a sudden there's no more air molecules and you're out in space. Okay, so those are the 5 layers: troposphere, stratosphere, mesosphere, thermosphere, exosphere. Now, you probably want to come up with a funny little sentence to help you remember that. Like for me, I said, the students make teachers excited. Okay, the students make teachers excited. The students make teachers excited. Yeah, that works. But you can come up with your own, whatever you like. Okay, now that's the stuff we talked about last week. Let's talk about new stuff. Heat transfer in the atmosphere. Okay, so we know that when anything heats up, the molecules in it start to move faster. Okay, and the faster the molecules move, they start to spread out. Okay, and as they start to spread out, they become less dense. When things start to cool down, the molecules move more slowly and they start to press together and the air becomes more dense. Okay, those are the 2 things you need to start with. And it's actually not just air, it's any gas and any liquid. Okay, when any liquid, any gas, they both work the same way. When they are hotter, the molecules move faster and they start to spread apart, and then it becomes less dense. When it becomes colder, the molecules move slower and they start to pack in together and it becomes more dense. And what happens then is that that's one of the things that will cause heat to move. All right, so we know that the on the Earth, the sun is hotter at the equators and it's colder at the poles. So how do we balance it out? I mean, like hot, like 120, 130, almost all year long. And the poles, are crazy cold. But how does the Earth balance it out? Okay, we use the air and weather to balance out the temperatures. So let me show you how it moves. Okay, you have, like I said, you have 3 different ways that the molecules can move. Convection is the one that as the molecules heat up, they spread out. Okay, and then that's the one here in this pot in the middle. Okay, you've ever seen a boiling water? Okay, where a pot boils and it looks like it's going in circles. Okay, because as something heats up, it thins out. Okay, and then it starts to cool and sink back down, comes near the eye again or the heat source, thin out, go to the surface, cool down, and sink. And at the same time, as this one goes up, the ones that are even hotter are pushing it from behind. And then even hotter, pushing it from behind, and even hotter, pushing it from behind, which actually makes this come back down, and then it heats. It takes a turn getting hot. So convection currents are that circular motion. So convection for circular. You have to find ways to remember them. Convections are circles. convection currents, a motion of heating and rising and cooling and sinking. You know that in the summertime, okay, before you had air conditioner, the bottom edge of the house would be cooler than the top stair. If you had a 2-story house, the bottom stories of the house would be cooler than the top stories. So what you did is that you opened the windows, and the heat would go out the top windows, and then the cooler air would suck in to the bottom windows, and it allowed circulation through your house. So convections are circles. Okay, now this next one, conduction. Okay, you actually have to touch it. The heat transfers from molecule to molecule to molecule till it burns your hand. This side of the thing is touching the heat source, and then the heat moves up and up and up through conduction. All right, so that's the second way, conduction, the transfer of heat from molecule to molecule to molecule up the end. Conduction has to actually touch the heat source. Radiation is the third one. That just means the heat radiates in all directions from the heat source. Radiation. It just goes out from all directions from the heat source. Radiation. So convection, conduction, you have to actually touch it. Radiation. So let's see then. Here's some examples of energy transfer. All right, now this is where I'm going to actually need you guys to answer with me. Holler off your mic if you can tell which one this is. Okay. An oven mitt gets warmer while transporting the baking dish. Is that conduction, convection, or radiation, do you think? Does anybody have any ideas?
Convection.
This one would be conduction because it's actually touching. Conduct, touch. This one's actually touching your dish. So that one is conduction. Let's try the next one. This one is actually two of them. Marshmallow heats over a fire. What do we call it when the heat goes out in all directions? That's radiation. All right. And because the heat is rising to toast your marshmallow, it's convection as well. So that one's actually two of them. All right. How about the sun causing the water to evaporate on the pond? How does the sun's heat get to us? Y'all can answer this one. How does the sun's heat get to us? Which one is that of the three? Okay. Which one is the heat coming out in all directions?
Radiation.
Radiation. Good. So this is radiation right here because the sun's heating up the pond. All right. How about this one? The air inflates the hot water. The hot air inflates the balloon. Which one is the cycle of heating and rising, cooling and sinking?
Who's the convection?
That's convection. Good. All right. Now the heat from the air is absorbed by the ice cubes. I've actually put the clues down here. That one's a harder one. But the hot air is actually touching the ice cubes and it starts it to melt. Which one is the touch? Which one is by touch? Conduction. Okay, the hot air is actually touching the ice cubes and that's what causes them to melt. How about this one? This hot horseshoe makes the tongs that you're trying to hold it with, makes them get hot too. That's another one by touch. What is it called when it goes by touch?
Conduction.
Conduction. Good. All right, how about this one? The pot's sitting on the hot burner. Again, it's actually touching, so that is?
Conduction.
Conduction. Good. This next one here, a bowl of oatmeal cools. That means the hot air is coming up off and then cycling through. Which one makes a circle?
Convection.
Convection. And then water warmed over a fire. This is two of them. Okay. When the heat of the fire goes out in all directions, what do you call it when it goes out in all directions?
Radiation.
Radiation. Good. And then because the heat is rising off of the fire, rising and then sinking and cooling, which one is that?
Convection.
Convection. So that's actually two of them, radiation and convection. And then we have this next one. The spoon gets warm after sitting in a bowl of soup. You have the spoon sitting there and it starts to burn your hand when you touch it.
Conduction.
Conduction, right. And then the microwave is using microwaves via the electromagnetic spectrum. So that should be radiation. I can't tell. Yep. That one was tricky to me also. But the microwaves are coming out in all directions from the source. All right, so that's radiation, whatever machine they've got in there. And this last one, the infrared heat sensor detects body heat. So you're shooting it out in a particular direction. So that would be what? It's not a circle. You're shooting it out from the ray gun. The ray gun, radiation. Okay. All right. Now you guys have a worksheet to do with that in a minute, but we want to know this. Where is your worksheet? Is that it down here? Yeah, that's it down there. Okay. But we want to know, this is pretty cool and all, trying to figure out how the heat is moving and all of these things. But what does that have to do with the atmosphere? This chapter is about the atmosphere. Well, let's think about how these things can work with the weather. The sun sending out its heat to the earth, that's radiation. When it hits the earth warms up and it sends heat out, that's conduction. And then as it goes, as the earth hits, because the sunlight is smack right on the ground, especially on pavement and stuff, that's conduction. The sunlight hit the pavement. But then the heat coming off starts to rise up, and that's convection. Okay, so that's all three. The sunlight comes down as radiation, it hits the ground and heats it up, that's conduction. But then once it's hot, it starts to rise. Okay, and that's convection. And convection is one of the things that'll cause thunderstorms and all sorts of crazy cool weather patterns. All right, so now we started off with the question, how does the heat move between the equators and poles? Because of all three of these working together, okay, and the spinning of the earth, we actually get these prevailing winds. Okay, it comes up off the poles, okay, and it hits and it tries to move up. The cooler air sinks down and then it hits the equator again and it moves up. Now, it would normally be one big circle, but the spinning of the earth breaks them into these bands. Okay, so that's how these three create all of the global winds. Do you guys have any questions for right now? All right, let's look at our worksheet. Okay, oh, some of you guys have already done it. That's awesome. So I put this picture back up here to help you remind. Okay, page 1, you're going to define conduction, convection, radiation, and identify what it means, which one is in each picture, like we did with the pictures we did. And then we're going to look at the situations on page 2 to tell which one is taking place, and there can be more than one. So let me see. Okay, so you're going to define each. All right, and just like we did, tell me what's going on. There could be more than one. All right, and then you're going to read this situation and tell me which one, conduction, convection, radiation, they're spelled here for you, which one is happening here. All right, do you guys have any questions for me today? All right, then let me get back over here and stop the video because I think we're just about ready. Here, and stop our video. We finally have Freddie in. Stop recording. All righty.